and then a more mature system in County Clare. And you wouldn't really know what it is if the fence wasn't there. It would look like a corner of reeds in the corner of the garden. The plants that we use are the bulrush, typha, and common reed, which is the one that's used for thatching. Yellow flag iris is another common one that's used in it. And then for stormwater wetlands and habitat wetlands, I like to include other plant species, a whole variety. This one is watercress. I don't recommend eating watercress from a sewage wetland, but certainly where you've got a natural habitat wetland, you can double that with foraging or food supply. And there's lots of ways to combine, to get multiple outcomes from the system. So that's constructed wetlands and reed beds in a nutshell. This is a graph that you're all familiar with, where basically our atmospheric carbon levels are too high. We need to get them down. So what do we do? And at the moment, we seem to be running around like headless chickens, trying to see, can we shave off a little bit here and a little bit there, and to reduce it a little bit, just to squeeze through the gap. But there's actually, we know that the damage is there already. These are photographs from the Hinch, top and bottom at the left-hand side, and flooding in Ennis at the right. We know that the damage is already happening. It's really, really clear that the weather patterns are changing hugely. But I think that shaving little bits off here and there is just it won't work. It's too late for that. Maybe in the 70s, if we'd started that, it would be okay. But we're too late for that at this stage. These three columns at the left are taken from EPA figures for carbon outputs for sewage treatment systems, well, converted from electricity requirements to carbon outputs. So let me see, the average 368 kilograms of carbon per year is the standard electricity usage carbon for a standard mechanical sewage treatment system. So for a media filter system, like a peat filter or a wood chip filter, it's a bit less because you only use the pump when the pump needs to kick in to pump the effluent, whereas these ones, they've got air blowers going 24/7. Now, constructed wetlands and percolation areas and reed beds are all carbon neutral. So they're all zero. But I think that in order to move forward, we need to make everything regenerative insofar as we possibly can. So this is the graph for zero discharge willow facilities. So what we've got here is the carbon soaked up by the growing willow trees. And this is where it gets exciting for me. It's because you begin to find systems in every area of society. It's easiest in sewage treatment and agriculture, but across every area of society where we can actively regenerate the landscapes that we're working in and completely reverse the carbon outputs. So this is a cross-section of a standard Danish willow system. You dig a great big hole, line it with plastic, backfill with some sand, top it up with soil, put on a spreading medium on the top, cover it over, and plant your willows into it. And there you go. So there's no discharge coming out of that. The effluent is pumped in from a septic tank, and then your willows grow rather enthusiastically. The front row there, that's 1 year growth. The photograph was taken in June in Denmark, and the coppicing would have been carried out in February of that year. So there's huge willow growth. And the back 3 rows of willows that you see, the tall ones, those are 2-year-old trees coming into their 3rd summer, and they'll be cut down at the end of that summer. So there's a cycle that goes back and forth. And what you end up with is generous quantities of biomass. And if they're used to offset fossil fuels, then you can get active regeneration, or you can make biochar or something along those lines to fix that carbon into the soil into the long term. How am I doing for time? I feel as if I've just got started and my 12 minutes is nearly there. I want to look very, very briefly at the simplified interactions between sewage treatment and agriculture, very briefly. Mainly we get energy from fossil fuels, huge inputs go into fertilizer, a certain amount goes into agriculture in terms of diesel and the like, and then standard treatment processes. We've got a lot of wastes coming out of that, a lot of carbon dioxide. We've got a certain amount of recirculation, feces turned to sludges and back to agriculture to a degree, but we can do a lot better than that, getting our energy mainly from solar and biofuels for agriculture. We can have urine diversion and fecal separation and composting to return basically the carbon from human waste biomass back to agriculture. And there's twice as much carbon fixed if you compost human urine directly, as opposed to composting sewage sludges. And then the excess from grey water goes to willow plantation for biomass, which it then sets up another loop between the atmosphere and carbon dioxide cycles. And briefly, you've got urine diversion toilets. This is a Norwegian development. This is a Swedish Aquatron. It's a vortex separator for fecal removal for composting. And then dry toilet systems for visitor centres and the like, or domestic homes offer a lot of solutions as well. Waterless toilets are increasingly common for water conservation, but they're also really useful for capturing urine, which you can just export to agriculture as a fertilizer. It's not for nothing that millions of years of evolution have produced pee from animals that's got just the right nutrient balance for trees. So, it's time to get away from the notion of sewage as a waste and really begin to look at it as a resource, and how do we manage that resource best for agriculture. I'm going to look, am I doing okay for time, Emer?
Yes, I think so. Orla, do you have the time there for it? I think so. You've another couple of minutes anyway.
I'll plow on with another couple of minutes. I want to look very briefly at SuDS and at buffer zones. So briefly, with SuDS, sustained urban drainage systems, we get our clues from nature very quickly as soon as the pipe stops. So we've got settlement of silt and the plants begin to push in, and that's our clue to what to do with stormwater. We can see already that the pipes didn't do much because they're spitting it out right here. This is from a very new housing estate, and you can see already the amount of silt that's accumulated in a little drain that we dug as part of the project. And then you can move from there up to ponds, stormwater ponds. This is a stormwater pond in UL, and you can see it's already serving as a habitat for ducks. This is the filter system along the side, a wetland filter along the side of the Ruski bypass. And this was one that we planted about, I'd say about 10 years ago at this stage. And that just filters the water as it runs off the roads. Again, for industrial sites, stormwater can be very good and can be doubled with habitat generation. I want to look at agriculture. If we simply plant up our drains, widening the drains, raising the water level slightly, that's a really, really good way for interconnecting nature, for creating corridors, and also for filtering the water that comes through. And it's got benefits for flooding as well, and for carbon sequestration, because you fix carbon in the plants themselves. So this is it in practice, really straightforward. Just widen your drain, shallow it out, plant it up with your wetland plants, and then the plants then thicken up into the long term. And there's new regulations that require filtration from roads, from farm roads specifically. And we can put in wetland marshes, ponds, drains and willow plantations, or even from runoff from fields. One of the things that we've lost over the years, and one of the things that's contributing to flooding a lot, is the changes in the land use. That as we put bagged nitrogen out of the fields, we strip away the humus material from the soil, and that allows erosion to flow more quickly off the land. And by putting in, well, compost in the fields is one, but by putting in riparian zones on sloping habitats or down along rivers, then we can soak up the water, reduce flooding, sequester carbon, and create wildlife corridors as well. Here we have a community planting day. Really straightforward. I want to emphasize the ease with which all these can be done. A couple of lads, a couple of boxes of yellow flags, make a few dams, and then by the time the day is over, you've got little pockets of wetland that'll hold on to the water. So anytime there's rain, rather than the water running quickly off the road and into the receiving stream, it gets held up in the landscape, recharges the groundwater, and filters it, creating a wildlife corridor. Leaky dams are another way to do it, either with straw bales, or you can borrow a beaver from somewhere. I think beavers and wilding generally are underrated. These are three of the most important water engineers that you could find, all taking a very, very important role in the landscape and doing it for free. We can replicate it, it just costs an awful lot, and we're never doing it quite as well. Each of these animals has their own important role in the landscape. The bison creates shallow margins. It exposes soil for new plants to come in. It adds nutrients and cycles biomass. But the bison needs the wolf to go with it to protect the river edge. Otherwise, the large grazers will eat into the river edge and cause erosion. They'll prevent overgrazing, and they'll modulate the grazer footfall in a way that's particularly conducive to creation of habitat. This is mainly for North America. This mind map here, I can send that on if anybody wants it. So as humans, we're a hyperkeystone species. We tend to be desert making, but I think we can turn that around and become oasis making instead. We're a very costly species substitute. I think there's a lot of potential for importing other animals to do the work for us. This is a small wilding project in Limerick. It's beside the Limerick Tunnel. So the tunnel sediments were dug out and spread into this area before reintroduction to the Shannon. And this was the design for re-implementing that area for wildlife. And this is the implemented aerial photograph of the area. So we can see a lot of the work that's been done here has replicated the role of the other animals, but it's quite a costly process to do. There's 3 core areas of rewilding. One is creating core habitat space. One is the keystone species, and another is the corridors. And this is that area beside the River Shannon again. You can see the kind of the equivalent of beaver dam space, but just more expensive to do it. So rather than looking at rewilding in terms of the keystone species, which can be quite a controversial one, we've got good core space within Mayo already. The Ballycroy National Park is an excellent wild, the Wild Neffin project. That's a fantastic core protected space as it is. I think that the river corridors of the county could become an excellent way to, to get animals interconnected, to put in the wildlife corridors, while at the same time also putting in filter wetlands for rivers and streams all over the country, protecting waterways that have a huge bearing on flooding and downstream habitats, sequestering carbon. All of those multiple benefits would be there. And I think that might be it. Oh, and we could combine it also with wild walkways and double it with tourism initiatives. And that's it. Thanks.
Cool.